see this on page 2. You'll have the two triangles. So what I want you to write, you can write this, and then I'm going to add to it these two, but leave some room so we can talk about them. Basically, you can use the Pythagorean Theorem to decide if it's a right triangle, if it's an acute triangle, or if it's an obtuse triangle. So here, it says C. Wonderful. It says C. What does this symbol mean?
Less than.
Less than. So it says if the hypotenuse squared is less than the leg squared plus the leg squared, then that makes it acute. So this is the way to look at it. You need to compare the hypotenuse squared to the leg squared. We use the Pythagorean theorem like A, B, then C. So what's going to happen whenever you solve this? You need to compare the hypotenuse to the legs. So here it looks really easy and you're like, oh, it's a less than symbol, so it's acute. But when you write it this direction, it's not going to be a less than symbol. It would flip. Does that make sense? So what you need to compare is that the hypotenuse has to be less than the legs squared and added together. And here, for obtuse, it's going to be the opposite. The hypotenuse squared needs to be greater than the legs squared and added together. So it's not necessarily that you'll look at the sign when you answer the question. You just need to compare the hypotenuse. What if the hypotenuse squared was equal to the leg squared plus the leg squared?
And it'd be a right triangle.
And then it'd be a right triangle. If a squared plus b squared equals c squared. Perfect. So this is going to pop up in orange, so don't freak out that I'm moving screens. So again, the obtuse triangles, the hypotenuse squared, it will be larger than. In acute triangles, the hypotenuse squared will be smaller than or less than. In this problem, these two problems, it first says to verify the segment lengths form a triangle. We did this a long time ago. It's very simple to do this. You add the two smaller sides, and they have to be bigger than the largest side. Sometimes some side lengths won't form a triangle. They're not long enough sides, or the ratios of the sides is too awkward to close the triangle. So that's all that wants us to check in the first place. So to verify, I'm going to write it above. So verify. All you do is you add the two smaller lengths, which here would be 90 and 20, or 216, sorry. 216. 90 plus 216 makes
306.
Is 306 bigger than 234? Yes. So then this is a triangle in general. Now we're going to decide what kind of triangle. All right, so we're going to use the Pythagorean theorem. Which one of these are we going to use for C? Yeah, 234, the biggest side. So we're going to do 90 squared plus 216 squared, and we're going to compare it. So I can't put equals because I don't know what it is. I'm going to compare it to 234 squared. 90 squared is 8100. I don't know 216 squared. 6656. What you said? Is that correct? All right, and then we're going to compare it to 234 squared, which is 54,756. What is 8100 plus 46,656? 54,756. So they're equal. So this is a right triangle. Are we okay with this? The second one, number 9. Again, we're going to verify. What are the two smaller side lengths here? 1 and 1. 1 plus 1 is 2. Is it bigger than the square root of 3? Well,
no. Yes.
it is. The square root of 3 is about 1.7 something, something, something. So it is bigger. So this is a right triangle, or sorry, this is a triangle in general. So now we're going to use a squared plus b squared and compare it to c squared. So which one will be c? The square root of 3, good. So that means 1 squared plus 1 squared. 1 squared is 1. What is the square root of 3 squared? 3. All right, and then 1 plus 1 is 2. So here is where you can't just look at the sign. The most common mistake, people are like, oh, well, 2 is less than 3, so it has to be acute. But that's not what you're looking at. Which one of these would represent the hypotenuse, or the longer side? 3. Is it smaller or larger than the leg squared? It is larger, which makes this obtuse. So in these problems, if you want to write it the direction that they did, like CAB, you can, and you can just look at the sign. Otherwise, it just takes an extra second of thought at the end. All right, we're going to move to the next page. This is a review of yesterday. Find the value of x, then tell whether the side lengths form a Pythagorean triple. Pythagorean triples. Did Pythagoras like decimals? No, so that's an easy way to remember it. A Pythagorean triple is just 3 whole numbers that make a squared plus b squared equals c squared. So, since it's a right triangle and it's missing a side, we're going to use the Pythagorean theorem. Which one of these would be c? 25. So then a and b would be 15 and x. 15 squared is?
225.
225. And then 25 squared is? 625. So we get 400. Take square root. 20. So if x is 20, is this a Pythagorean triple? Yes. All the side lengths are whole. The next one, the flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. So what do I know based on the fact that both of them are named x? What do I know about the lengths of the wires? They're the same. So what you can do, since this is a section about what kind of triangles? It's about right triangles. So we can just look at one of the right triangles. We know we have 8.5 feet from the pole to the end of the wire. What is the length, or the height of the wire? 15.1 is the height of the wire. So now to find the missing side, we're going to use the Pythagorean theorem. Which one of these would we label C? X. So we're going to say 8.5 squared plus 15.1 squared equals x squared. 8.5 squared is 72.25, yeah? 15.1 squared, I don't have that one memorized. 0.01? Okay. All right, we're going to add them together. 300 what?
300.26.
Take square root. 17 point what?
3.
Good. And it would be feet. 17.3 feet. right, we have two more. I know you don't have the second one, so I'll give you a minute in a minute to write it down. But we're going to do this one first. Tell whether each triangle is a right triangle. So to see if it's a right triangle, we still use the Pythagorean Theorem. We're going to see if a squared plus b squared equals c squared. So which one of these would we label as c? 12. So what you could do is type in your calculator 4 times the square root of 5. I'd venture to say it's around 9-ish. Am I right? 8 point something or possibly 9 point something. Oh, you haven't done it. Okay, so anyways, 12 is the longest side, so we're going to use that as c.
Yeah, it's 8.9.
Yeah, there you go. We're going to leave it in the radical in a second. So we're going to call 8a and 4 square root of 5b. So what do we need to make sure when I go to square this? It's in parentheses, and the square is on the outside. Good. 8 squared is? 64. I'm going to take this off to the side. 4 square root of 5 squared. So the easiest way to do this is square the 4 and square the square root. What's happening between a number and a radical? They're being multiplied. Good. So 4 squared is?
16.
And the square root of 5 squared is 5. 16 times 5 is? It's what? 80? Okay. Yep, 80. And it equals 144. 64 plus 80 is? 144. Does 144 equal 144? Yes, so this is a right triangle. Then I'll give you a minute to write down the question on the right. It says verify the segments with lengths of 14 meters, 15 meters, and 11 meters form a triangle. Is the triangle acute, right, or obtuse? So first to verify, we're going to take the two smaller sides, which would be 14 and 11. 14 plus 11 is 25. Is that bigger than our largest side? Yes, so this is a triangle in general. So then we're going to use the Pythagorean Theorem to compare the hypotenuse squared to the legs squared. So which one of these would be the hypotenuse? 15. So that means the other two would be 14 squared and 11 squared. 14 squared is 196. 11 squared is 121. And then 15 squared is 225. Add 196 and 121 together and you get 217. No, 317. Yeah. All right, so a lot of people again would say, oh, well, there's a greater than. But what you want to look at, this is the hypotenuse squared. Is it less than, greater than, or equal to? It's less than, so this is a cute triangle. Such a cute triangle.